Stanford University.
Well, welcome to lecture number 17 of Stanford CS 193P. This is fall of 2017. Today we're going to talk about some hardware-specific APIs, specifically core motion, which is the position of the device in space, basically, as it moves around, and then the camera, so we can capture images with the camera. Now, core motion is really a whole set of APIs that go together. The primary inputs to core motion are the accelerometer. Almost all devices have an accelerometer. The gyro, most newer devices have a gyro. And the magnetometer, kind of similar to the gyro. Newer devices have all that. And you're going to see as part of the API, we're really going to want to check and make sure that the device we're on has the hardware we want before we do it. Now, the primary API to get at all this is this class called CM Motion Manager. There's some other classes we're going to talk about, but this is the primary one. Now, you can create multiple instances of this thing, but in a sense, there's only one set of hardware. So usually in your app, you're going to have one shared CM Motion Manager to collect all the information from these devices. Now, the way the API works, basically, is you're first going to check to see what hardware is available. All right, that's a very important check. Then you can either start sampling, okay, just asking the CM Motion Manager, what's the current state of the accelerometer? What's the current state of the gyro? What's the current state of the magnetometer? Or you can register a closure and a certain refresh rate, and it will execute your closure at that refresh rate as best it can anyway, and tell you what the state is. So it's kind of like you can either pull the data out of it, or it can push the data to you. Really, either model, and it kind of depends on how your app works as to which of those is appropriate. So I'm going to talk about the APIs for both of those things. So let's do number one here, which is checking the availability of the sensors. Really, really simple. You're just going to get your CM Motion Manager, and then you're going to ask questions like accelerometer available, is gyro available, magnetometer available, and this is just going to return yes or no whether these things are available. Notice that there's something there called device motion. You see accelerometer, gyro, magnetometer, and device motion. So we're going to talk all about device motion. It's essentially a combination of all the other devices, and it allows us to get much more accurate readings, more interesting readings by combining the accelerometer, gyro, and magnetometer. So the way where you're going to pull the information, okay, not going to register a closure, but you're just going to ask for it as you need it. You do that by calling start accelerometer updates or start gyro updates, and that's going to tell the hardware, tell iOS, hey, I want to get this information. So, you know, if that particular piece of hardware has to be like powered up or something like that, then iOS is going to do that so that you can start asking the value of it. So that's all you have to do to start pulling the data. You can also find out if the hardware is on and collecting data with accelerometer active or gyro active VAR in the CM Motion Manager. Now, a really important thing to do when you're accessing this data from these hardware devices is to turn it off. Okay, and the reason you want to turn it off is it requires battery. Okay, who knows how much? It depends on the piece of hardware to do this, and you don't want to waste the user's battery. All right, so we definitely want to turn it off anytime we're not using it. Not like just when our app quits or something, but actually anytime we are not actually going to use the information, let's turn that thing off. Right, save some battery. All right, so now let's talk a little bit about that pull interface where you're just going to ask for the current state of this thing all the time. And the API is very similar for all the devices, gyro, accelerometer, and magnetometer, and for this combined device motion thing. So here's what it looks like for accelerometer. It's just a VAR in CM Motion Manager called accelerometer data. Gives you back a struct. It looks like this, X, Y, and Z. That is the acceleration of the device in X, Y, and Z. So X is the axis that goes up across the device. Okay, so if you're looking at the device and the home button's at the bottom and you're looking at it, then across is X. Y is up and down through the home button essentially, or if you have an iPhone 10 through where the home button used to be. And then Z is down through the back of the device. Okay, so if you had a device sitting on a table flat, then Z would be 1.0 here, because this is in G, and the only acceleration that the device would be experiencing is the acceleration due to gravity. Okay, don't forget about that acceleration, right? 9.8 meters per second squared towards the center of the Earth. That's always happening. So if you then pick the device up and kind of set it down so the home button was on the bottom, right? Then your Y would be experiencing 1G, and Z and X would be 0, okay? because nothing would be moving it. Now, if you took the device and you shake it all around like this, then X, Y, and Z are going to be all kinds of random numbers. Could be much greater than 1. If you really jerk it, much faster acceleration than the acceleration due to gravity, you could get all kinds of numbers. All right? So this is giving me the raw acceleration of the device in space, including gravity. All right, the gyro. So the gyro, we're almost never going to ask for the gyro information directly like this, as you're going to see in a motion. But if you did, it's essentially going to tell you the rotation rate around those 3 axes I talk about in radians per second. Okay? So it's basically how fast it's rotating in these devices. Now the problem is the gyro on its own can get bias introduced to it. It can kind of drift a little bit. So the gyro works a lot better in concert with the accelerometer, as you'll see in a moment. And similarly with the magnetometer, yeah, you can find out the magnetic field around you, but you know, you'd like to know how much of that is the Earth's magnetic field, so you can find out where north is, versus how much is just local interference from devices. And so we don't usually access the magnetometer directly either. Instead, in both cases, we access this pseudo device called device motion. Okay, and so it's similar to the other ones. It has a var. This one's called device motion, and it gives you back this device motion struct. Now, the device motion struct is giving you a lot of the same information you're getting from these other devices, but it's combining the devices to give you better information. For example, let's look at acceleration. So when you have a device and you're looking at the accelerometer, you don't really know how much of that is due to the acceleration due to gravity and how much is because the user is moving the device around, right? Well, but if you have the gyro, now you do know how much the user is moving the device around. Okay? So if you combine the two, you can factor out the acceleration that's due to gravity and the acceleration that's the actual user moving the device. So in CM motion, you have the gravity, which is a CM acceleration, and you also have user acceleration, and they're separated out. Okay, so you see how it's used the gyro to give you more information about acceleration. And similarly for the gyro, okay, if you have this gyro, you can remove the bias that happens with the gyro because you have the accelerometer information that tells you where this thing is being moved around as it's being rotated. So there you can get rotation rate in the same way as got before, but you can also get much more interested in things like roll, pitch, and yaw. Okay, so if you know anything about flying, if you have an airplane that's flying along, the roll is when the airplane tilts its wings side to side, right? That's the roll. Pitch is when it pitches its nose up or down, right? That's the pitch. And the yaw is when it kind of turns into the wind in the same plane parallel to the ground, right? So you can get that same roll, pitch, and yaw in your device, okay? Which is really kind of a cool way to think about your devices, what your device is doing. You can also get heading. Okay, now it needs the magnetometer for that, obviously, to do the heading. And this can give you the heading. And heading is sometimes interesting to have if you have, for example, an augmented reality app or something like that, where you want to know the gyro position as you're moving this thing around, but you also know where you are in the world. Are you facing north? You know, where are you facing? So it can give you that information as well. So see, device motion is probably the primary way we get information out of core motion when we want gyro, accelerometer, and magnetometer because it combines them very intelligently. Okay? Now, when you're getting device motion, you can actually control which of the devices, accelerometer, gyro, and magnetometer, are used, specifically the magnetometer. Okay? There's a couple of reference frames, and reference frame is just an argument when you start getting the updates from the device motion. So there's 2 reference frames called X arbitrary Z vertical and X arbitrary corrected Z vertical, which either don't use the magnetometer or can work without the magnetometer, I believe they can do. And so they really aren't used for a reference frame when you want to know where your device is in the world. Okay, so there's 2 other ones, X magnetic true north and X magnetic north vertical and X true north Z vertical, and those use the magnetometer. Now those actually will require the magnetometer to be calibrated and ready to use, so you know, you don't want to use these reference frames lightly, but if you need to know where you are, then you need this. Obviously for true north, it not only needs to know all the information that we talked about so far, but it also needs to know your location, where you are in the planet, so we can tell the difference between magnetic north, which is the only thing it can measure, and true north, okay? And that just depends where you are on Earth. Now, if you want the heading var that I talked about on the last page from device motion, you'll obviously need to have the reference frame be either magnetic or true north. All right? Now, always check to make sure that whatever reference frame you want to use, especially if it's going to be the magnetic or true north ones, is available. And you can do that with the available attitude reference frames function. It'll return one of these frames above, and you can it's a bit mask, and you can look in there and see if yours is available. All right, so we talked about how to just grab the information, whether it's accelerometer data or this device motion data, grab it from CM Motion Manager. And how about the thing of registering a closure? So that API looks like this. For accelerometer, for example, you're going to say start accelerometer updates to queue. That's the queue that your closure is going to be executed on. That's almost always going to be the main queue. So you're going to say .main there usually, with a handler. And the handler is just a little closure that takes two arguments. One is the accelerometer data that it's giving you in its updates, and the other one is a possible error. And one of these is always nil, okay? Either got the data or it didn't. It's as simple as that, okay? So you're just going to get called, this closure is going to get called repeatedly with the state of the accelerometer, similar for the gyro, similar for the magnetometer, and similar for device motion. Okay, notice that device motion also has this extra argument at the beginning, which is that reference frame I talked about, okay? Now, what about the errors that can come back here? Okay, well, it all depends on what you're asking for, especially in device motion world. If you're asking for something like true north reference frame and you're trying to get the heading, you might get the error true north not available. Maybe because it doesn't know where you are on the Earth, okay, because it can't see any cell sites or Wi-Fi or GPS or anything like that, so it doesn't know where you are. Also, you can get not authorized and not available. I'm going to talk about that in a second, where the user might have said, I don't want this app to be able to get this information from me. Okay, that's from a privacy standpoint. Okay, so you want to look in the documentation and see what the errors you can get are and handle them. Core Motion, it's the same thing with the core location, the map kit. It's a place where you really want to handle the errors. You don't want to blindly ignore errors, because these errors do come up. Okay, we're talking about physical devices here. The real world, it's variable. Okay. So how often does your closure get called? Well, you get to determine that by setting one of these VARs, the accelerometer update interval or the device motion update interval. This is a time interval, so that's number of seconds. And usually you're going to set it to maybe 1/10 of a second or 1/30th of a second. Maybe you could do 1/60th of a second, but you're really pushing it by then. And remember that it's going to be calling your closure, so unless your closure is really lightweight, you don't want to call it too much. So how do you decide what to set this to? Well, it totally depends on what's happening in your app. Okay, you're going to see in the demo I'm going to do today, I'm going to use the accelerometer. It's not that important to see really quick changes in the accelerometer, so I'm going to go a fairly low rate. But I might have something that's a very detailed thing where I'm looking at the accelerometer and I want to know exactly what's happening and the user's using it, moving at tiny little amounts. Then I might want to be updating very quickly. Okay, so there is a limit, of course. The hardware can only deliver a certain limit. I'm not sure what those limits are, probably around a 1/60th of a second kind of thing. But that's something you have to tune to make your app work well. It is okay, by the way, to register multiple closures, okay, inside your app, have two different things, although they're all going to want to be updating at the same rate. Okay, and if they're all registered with the same motion manager, they will all be updating at the same rate. Okay, it's not really recommended to have two core motion managers with different rates and different closures, because you could get a performance issue there where it's trying to service both of those rates and it's having to call them a lot, so be careful with that. All right, so we understand then how to get the accelerometer data, the instantaneous value of the accelerometer, but really accelerometer data sometimes makes a lot more sense over time. Okay, like what's the average amount of movement in the last minute or something like that. Maybe you're trying to see what the user is up to, what they're doing, kind of how they're moving around, or they're walking around, what they're doing. So there's another class in Core Motion called CM Sensor Recorder, and it can record at 50 hertz what's going on. Now, only newer devices, I think iPhone 7 and later, can do this, so you definitely want to say, is accelerometer recording available? This is also something that's on the Apple Watch, which is very useful for that. Then once you do it, you just say to the CM Sensor Recorder, record accelerometer for some duration, and it will start recording it. Okay, and you can say what the duration is. Now, I recommend keeping that duration as short as makes sense for your app, okay, whatever's going on, because it's expensive to turn that accelerometer on and record. However, this is really, in a way, less expensive than doing some other things, because most iOS devices, in fact, probably all of them that can implement this, they know how to go to sleep, right? The screen turns black, they're asleep, the processor's not really running, but that thing is still collecting accelerometer data. right? So they've separated out the accelerometer hardware into a separate little chip that knows how to collect data and then report it back when the system wakes back up. So it is possible, you want to go for a run and your app wants to measure the person's acceleration in 3 dimensions while they're running. Well, they put it on their arm or in their pocket or whatever, and it goes to sleep because they're not running your app. And they're running, they run for an hour and they come back, and the data can all be there without the app having to constantly run and ask for it, okay? And there's a lot of fitness API that I'm not talking about here in Core Motion that is in that same vein, where you can kind of ask the system, please record these things for me, and then you get them later, you ask for them later. For example, this quarter I didn't get to talk about core location. Okay, core location is something I highly recommend you look into possibly for your final project. And core location can record your GPS or otherwise location, and it can do it in a way that doesn't cause the phone to have to be awake all the time. All right, so once you start a recording, then you can go back and get the recorded data. It only keeps the recorded data, I think, for 3 days, so you want to be asking for it in a reasonably timely manner. But you can ask for the accelerometer data during a certain time, and it's going to come back as this CM sensor data list, which you just basically in to get CM recorded accelerometer data, which is just going to be that XYZ of all that stuff, and you can look through there. And usually you're going to take that list and average it or something like that to try and figure out what's going on. Now, if what you're doing is looking at that accelerometer data because you want to try and figure out is the user running or staying still or walking or in a car, then you don't want to use that. You want to use this API. Okay, there's an API called Activity Monitoring that will use a different object here. It's not the CM Motion Manager. It's CM Motion Activity Manager. And it's a very similar API. You say start activity updates, and you have a closure, and it will call that, okay, periodically telling you what the user's doing. Are they standing still? Are they walking, running? Are they in their car, cycling? This is a really powerful API. It's using a lot of input to try and figure out what's going on here. It's been very finely tuned, especially for driving because of this new Do Not Disturb feature in iOS 11. So this is how you would want to try and figure out what the user is doing rather than trying to look at their accelerometer data and figure it out. Okay? This data is stored, I think, for a little longer, maybe like 7 days, I'm not sure. But you can go back and look at this data with a from and to. And again, it's going to call you with the information, and you can get all that. Now, in addition to that, you can also get pedometer information. So steps, users walking around, what are they doing? Similar API, start updates, you get a closure, it calls you back. Pedometer information really only makes sense over time, right? You're not going to ask like, how many steps are you taking right now? Okay, you're in the middle of a step. No, it's like, how many did you take in the last hour? Have you taken in the last minute or whatever? So when you call this, you get back a struct that has a start date and an end date of the recording that it made, and it'll tell you how many steps were taken, how far they walked, how many floors they went up and down, stuff like that. Okay, so pedometer, if you're doing some kind of fitness app or something like that, pedometer's a cool thing for that. You can also find out altimeter. Okay, now this is relative altimeter. It can't tell you exactly what your altitude is because really it's just measuring the barometric pressure around you. But as you go up and down, of course, that pressure is going to change, and so it can give you a relative altitude change. Okay, now let me talk a little bit about authorization for all this stuff. Some of the information here that we're talking about is considered private to the user, like their steps information and what they're doing, standing still, driving, that's private information. So if you want to get that information, the system is going to ask the user, is it okay to share this information with this app? And they're either going to say yes or no. So you, if you're going to use this private information, need to check the authorization status before you go and try and access this data. Otherwise, it's just going to fail and give you an error that explains it. But this way you can avoid that, even wasting your time calling that. And here's the authorization statuses you can get. You can have not determined. That means the user hasn't been asked yet. Okay, so we don't know what it is. Restricted means the user can't be asked, okay, about this, maybe because they've just turned off fitness tracking on their phone in their privacy settings. So it's not, they're not even going to have you ask because the user just told me no apps can do any of this fitness data. Or it's either denied or authorized if they've been asked, okay, what their answer is. And of course, they can go back and change this in their settings, right? So if you have an app and it depends on this, and you check this, it says denied, you can put up an alert that says you denied me the access to do this, so I can't do this feature. If you want to re-enable it, go to settings and do it. All right? Okay, so the demo I'm going to do is a super little simple one. I'm not even going to use device motion. I'm just going to use the accelerometer. We're going to take our playing card app, if you remember that app from many weeks ago. And remember, it has the cards flying around. Here, let's actually go and run it. Here it is. I'm going to run it on my iPad over here. So here it is. Remember this app right here? I got the cards here, and I've got my iPad here, tapping on it. Okay. Woo, I got a match in the very first cards. So what we're going to do is make it so that these cards are affected by gravity, real gravity. Okay? We're going to make it so that the cards go towards the center of the Earth, basically. And we're going to do that with the accelerometer and measure the acceleration due to gravity. Now, again, I'm not going to use device motion, so if I shake my iPad around, they're going to start flying around, and not too fast because it's just acceleration, it's not actual motion. But so we're not going to worry about that. Okay, if I didn't want that, which I probably wouldn't, then we'd use device motion. But we're trying to save time because we've got a lot to demo today. So we're just going to use accelerometer. So let's jump back here into playing card. You all remember it here? We got this pile of playing card right here. So how are we going to do this? How are we going to make our cards be affected by gravity? Well, it turns out that there's a behavior. One of the animation behaviors is gravity behavior, and you can specify the magnitude and the direction that the gravity is coming from. Okay? And so what I'm going to do is just, as my device tilts around, I'm going to change where gravity is so that it goes towards the center of the Earth. And that's really easy to do in playing card because we already have this card behavior, right? Remember this subclass of UI dynamic behavior that handles our collisions, like do we allow rotation, when we push an item, etc. And we've just added those things as our child behavior. So I'm going to do the exact same thing for gravity. So I'm going to create a new behavior. I'm going to call it my gravity behavior. It's going to be a UI gravity behavior. And I'm actually going to initialize it in exactly the same way that I did these other ones up here, which is to use a closure, right? I'm going to execute a closure to initialize them. So here I'm going to let behavior equal a UI gravity behavior. Now, the only initialization I'm going to do at the start here is to set the magnitude of the gravity to 0. Okay? Now, you can even control what the magnitude of the gravity, and remember, we're not talking about real gravity here. We're talking about the gravity that affects the animation of these items, right? So you can set that to anything you want, okay, whatever gravity you want. So I'm going to set it to 0. And the reason for that is, remember I said that we don't want to turn the accelerometer on until we're on screen. And as soon as we go off screen, we're going to turn it off because we don't want the accelerometer on. So until I turn the accelerometer on, I want no gravity to be affecting my cards. So they'll just do what they normally do until I hook it up to the accelerometer. All right, so there's our behavior. Now, anytime we have a child behavior like this, we're going to want to make sure that new items that we add to it are added so that gravity affects them. And of course, if we remove an item, we want the gravity to stop affecting them. Oops. And we always need to add any of these behaviors as a child behavior like this. Okay, so now our card behavior up here that we defined up here. Now, in addition to doing collisions and having this other item behavior and being able to be pushed and all that, it's also affected by gravity, which starts out 0. Okay, so now that we can do that, let's go back to our controller. This is our view controller where we make all the cards and all that stuff, and it knows about the card behavior. And I'm going to turn on the accelerometer when we appear, and I'm going to turn it off when we disappear. And when I turn it on, all I'm going to do is register a closure that takes the accelerometer's data and puts it into that card behavior's data. All right, so let's do that. I'm just going to first do view did appear. Okay, super. View did appear, animated. All right, and so in view did appear, the very first thing I'm going to do is figure out how to get my motion manager going on here. And the way that I'm going to do that is by creating a shared one. Because really, I can only have one, as we talked about, motion manager per app. It only makes sense to do one. So I'm going to do that actually in another file. And I want to show you a little bit what the conventions we might use are to create something in a file. Now what I'm going to create here is an extension to CM Motion Manager to add a static var, which is the shared one. Okay, and so that's how people will get it. So usually we call files that have an extension in them like that the name of the class that we're extending, and then plus sign, and then a description of what's in there. In this case, it's going to be shared, a shared one, so I'm going to call it shared. So this is called CM Motion Manager plus shared. It doesn't want to import Foundation. Instead, it wants to import Core Motion. Okay, anytime you do anything with Core Motion, you need to import Core Motion. So I'm just going to have an extension to CM Motion Manager, and it's just going to be a static var, so a class var, right, called shared, which just is an instance of CM Motion Manager. So now anyone who wants to use a Motion Manager can use this one right here, and they'll all be sharing the same one. Now, of course, our simple app, we're only using it in one place, but I just want to show you this is how you could do shared data if you wanted to in your app. All right, so view did appear is happening here. We want to turn on the accelerometer. First thing we always do is what? Check to make sure we can do it. Okay, so let's do that. I'm going to say if the CM Motion Manager. Now, I'm not getting escape completion. That's because I need to import Core Motion in here as well. If I'm going to use Core Motion, I need to do it. And now it's figuring it out for me. I'm going to do shared. And I'm going to call the method there to check to see if my accelerometer is available, called isAccelerometer available. And if it is available here, then the first thing I'm going to do is tell my card behavior to have its gravity behavior turn its magnitude back to 1.0. So we're going to turn on the gravity in our card behavior. Then we want to register a closure with the Motion Manager to call us with accelerometer updates. And we do that by saying CM Motion Manager.shared.start accelerometer updates. And you can see here's the one where you pull, and here's the one where we get the closure. So we want the one with the closure here. We're going to do it on the main queue. Okay? And the handler, we'll just double click. And you can see the handler has the argument here, which is the data. That's the accelerometer data. And it has a possible error, which could be nil. Let's use the closing trailer, the trailing closure syntax here. Make that work. So this is all we need to do to get these updates. Now, how often are we going to get these updates? Well, we get to say CM Motion Manager dot accelerometer update interval. Update interval. What is it called? I can't type here. Called let's just go update interval. No. Oh, sorry, .shared, accelerometer update interval. And, okay, think about what's happening with these cards, right? They're being pulled by gravity going on. They don't need to know instantly what the gravity is. In fact, probably once every half second would be enough, but to be sure, I'll go maybe once every 1/10 of a second. Okay, I don't really do much in the closure, so it's really not a performance hit to change that too much. So we'll go about every 10th. We could go 5th. We could kind of tune this. We might find that once a second is enough to get the behavior we want, in which case we should use once per second. So this is something you have to tune. All right, now we want to get the accelerometer data. Where is it? It's in here. This is that struct that has the acceleration, x, y, and z. So I'm going to say if I can let x, which is going to be my acceleration in x, equal that data, if we have it, if it wasn't an error, acceleration.x, and I'm going to let y equal the data, acceleration.y. So if I'm able to get the information, if I can't, I'll just ignore this. I'm going to ignore errors. I should handle them if I need to here, but I'm going to ignore errors. So if that comes through, now I need to set the gravity vector, okay, the direction of gravity, in my card behavior's gravity behavior. Okay, now this is an interesting thing here to want to do, because the accelerometer data is with respect to the device. Okay, if I hold this device up right here, okay, here's the home button, down, that means that in the y direction, this is gravity 1.0, okay, and this would be kind of, if it was going up, it would be negative gravity right here. And this is the x direction, and this is the z direction back behind, okay? So that's different than, possibly, my reference frame of my animation. Because, for example, I might be rotated, okay? So if I'm rotated, maybe my app does auto rotation, and so up is actually the x location. Do you see what I'm saying? So the hardware and the view are not quite the same. Now, before we try and deal with that, let's just try saying that the card behaviors, gravity behaviors, direction, gravity direction is called, which is a CG vector, which just means x and y extent, right? We'll just try setting it to the x and y of the accelerometer. Let's just see what happens when we do that, okay? Because that kind of should work. Let's run and see what happens here, though. All right, so you can see what's going on here on this screen, okay? I'll have to tell you what I'm doing. So here, I'm holding my device now straight up, okay? And you can actually see, look, all my cards are actually going up. If I turn it upside down, now they'll fall down. Back to right side up, woo, they all go back up. So gravity is working, but it's kind of anti-grav, okay? It's working opposite direction. Now, can anyone think why it's going the opposite direction and why? Okay, where's our origin in our drawing thing? It's in the upper left, right? So if we have gravity which is down, where is down in a coordinate system where the upper left is 0, 0? It's up, right? It's up towards 0, 0. So that's the problem. So we need to kind of reverse y because the device gravity down is different than our coordinate system. And actually it could get worse. Right now I have my orientation locked. So as I rotate my device, it's not auto-rotating. But if I auto-rotated, then my view would constantly be changing. So how are we going to fix that? Let's go back to our code over here. And what we're going to do is change this x and y from hardware coordinate system to our view coordinate system. And we're going to do this. I'm going to have a little thing to type it fast here. We're going to do this depending on the orientation of the device. So I'm switching on the device's orientation. So remember we used UI device to see if it was an iPad. Well, we can also use UI device to find out what the orientation is, either portrait, portrait upside down, that means portrait with the home button up on the top, or landscape left or right. Landscape left is the home button on the left, landscape mode. And of course, these need to be vars. And by the way, yes, you can say if var x and have this be a var. That is legal. Probably maybe didn't get that when you read your homework part of it early in the quarter, but you can. So if I'm in portrait mode, then we've already seen that y needs to be -1, right? Because up is down and down is up. If we're in portrait upside down, they actually match up. Okay, in portrait upside down, the home button is at the top, and so is our coordinate system, so we're all in good shape. And landscape left and right, actually x and y have been swapped. Because in landscape, it's the x part of the device that is now the vertical. So we'll have to swap them. And in landscape left, we swap them, and it's upside down as well. So let's go see this in action. And we're currently locked to portrait. Okay, first of all, now I have my device. Let me get this up here. So now my device is flat. Okay, so acceleration is in the z direction, so x and y are 0. So you can see it's just doing its normal floating around business. Now what I'm going to do is I'm going to tilt it up so the home button is down. And sure enough, gravity pulls them all down to the bottom. Now I'm going to turn it upside down. Okay, now gravity is pulling it all to the other side. If you're watching on the screen, you can't really understand what I'm doing maybe. But now let's go to landscape right, and over to landscape left. Okay, so it's working. Gravity is pulling on these things. They're still bouncing off each other and have those forces as well. But they're doing that. Now, I'm going to unlock my rotation here. I'm going to go swipe from them, turn this lock off and go back. Now it's going to auto-rotate. Okay, so here we're in portrait mode and it's all go to the bottom. Now if I go flat, for example, and all my, so let's actually go here and get these things floating a little bit. And if I go to landscape, you can see that they stay at the bottom. Okay, so they're staying down at the bottom no matter which way I go. So even though my coordinate system is changing here because I'm auto-rotating, it's always knowing which way is down. Okay, make sense? All right, go back to locked here. There we go. So now we can see it going in other directions. All right. Now, one other thing we have to do here back in our code is turn off accelerometer updates, okay? Because we always want, anytime we turn it on, think of somewhere where it makes sense to turn it off. In our case, it's really easy where that is. That's going to be in view will disappear. So let's go in view will disappear. Super.view will disappear. And here we're going to do two things. I'm going to tell my card behavior's gravity behavior to set its magnitude to 0, okay, to stop doing gravity. And I'm also going to tell my CM Motion Manager, the shared one, to stop accelerometer updates. Okay, so you see how I've paired starting it with stopping it. Always start and stop. Okay, that is it. Let's go back to our slides here. Talk about our next topic, which is the camera and the photo library actually as well. And this API for doing this is actually very simple. It's just a modal view controller that you get from iOS, and you present it modally. That's as simple as that. The usage here is that you're going to create it, kind of configure it, set its delegate, because it won't work without the delegate. That's how it tells you what the photo it took was. And then you present it, and then listen to the delegate methods that get sent to you. So it's actually very simple to use the camera. What the user can do, by the way, with the camera depends on the platform. Right? Newer devices have really awesome cameras, both front and back, for example, with flash and all these things, but older devices don't. So just like we did when we did Core Motion, we're going to want to ask what's available. Now, what's interesting is with this same view controller, you can ask for a picture from the camera, but you can also ask for a picture from the user's photo library or from their camera roll, right? The camera roll is where kind of recently taken photos get dropped in. So the same view controller can kind of do those different things, but they are different. Okay, the UIs of them are quite different actually, and we'll talk about that in a second. So not every particular camera can do every type of media. So not every camera, for example, can do video. Not every camera can do live photo. Everyone know what live photo is? That's like where it takes a burst of images around the time you say picture. So you kind of have to ask, is this media type available for this source, usually the camera, okay, and you do that here. Now, these media types are really, unfortunately, this weird type here, KUT type something, which is not even a string. It's a CF string, it turns out, and that doesn't automatically bridge like an NS string does, and they're defined in mobile core services, which means to use camera, you have to import mobile core services, and you have to use these and cast them to a string. Okay, so sorry about that. I didn't write this API, so we'll see. I hope they fix that in the future, but it's a little annoying. You can also find out things about particular camera devices, like do they have flash and things like that. That's all part of the UI image picker controller. Notice that all these methods are static funcs. You don't even have to create a UI picker, image picker controller to do it. You can just ask the UI image picker class about these things. So here's kind of collecting all that into some code that would put up a picker to capture video. All right, so the first thing we're going to do there is create an image picker controller called picker. Okay. Then I'm going to set the type that I want to be movie. I'm going to create a little local variable, media type movie, which is just that weird KUT type movie thing, as a string. Okay. Now I'm going to set myself to be the picker's delegate. If I don't do that, I'll never find out what photo was taken, so I have to do that. It's an absolute requirement. Then I'm going to ask UI image picker controller. By the way, I say UI IPC because it just won't fit on the slide some places, so imagine that it says UI image picker controller. Is source type available? Camera. So I'm going to see, is there a camera available on this device? Which, for most things, there is a camera. The simulator, however, will not have a camera, so it's a good way to test this line of code. Then I'm going to set, if it does have a camera, I'm going to set the source type of the picker to be the camera. Okay, don't forget to set the source type where you want to do it. Now, this source type is where you would say photo library if you wanted to let the user choose a photo from the photo library instead, okay, or the camera roll. So then we're going to say, tell me the available media types for that source, camera or whatever source type that I'm using. And I'm going to look in the array that comes back and see if movies, KUT type movie, is in there. And if it is, I'm ready to go. I'm going to set my media types to be movie, and then we're going to put the picker up. So this is how you put a picker on the screen. All right? Now, when I told you earlier that you can configure this picker, okay, to when you're putting it on screen, what are some of the things you can do? Well, you can just say that it allows editing. So in that sense, the user can take a photo, and then even before it comes back to you, they can zoom in on it a little, move around. Video, they can even edit the video before it returns to you. So it basically has in-place editing right in the UI that UI Image Picker controller puts up, which is kind of cool. You can, if you're doing video, you can limit the video capture to a certain number of minutes or to a certain quality using these VARs right here. To present the picker, all you do is use the same present modally that we did to do a UI alert controller, or the same thing we did to put our document up in emoji art. And here's where you want to think a little bit about the platform you're on. Because on an iPad, if you're going to put the camera up, it needs to be full screen modal. You cannot put it in a popover if it's the camera, okay? Don't put it in a form sheet. Don't put it in a page sheet. Full screen modal, okay? That's actually on both iPad and iPhone. On the iPad for the photo library or the Photos app, you want to put it in a popover, okay? And then on the other phone, it's going to be full screen always on the iPhone. Okay, so just clear about, I just want to take a moment to make sure that sinks in. On an iPad, full screen for the camera, pop over for the photo library, okay? So if you had an app where you could pick your image either from a camera or from a photo library on the iPad, you'd have to have two buttons, one that brought up the camera and one that brings up the photo library in a popover. Okay, once the thing has been presented and the user picks and possibly edits their photo, then the delegate method will be called, saying that it did finish picking media with info, okay? And this info is a dictionary, and inside that dictionary is all the information about what was picked, okay? And we're going to talk about what all that is on the next slide, but this is how you get the information. Now, once you've got all the information, you're going to dismiss your view controller, okay? This is actually old slide here. That's just called dismiss, not dismiss view controller animated right there. And so similarly, if the user went to take a picture and said cancel, then you're going to get the delegate method image picture controller did cancel, and you're going to do picker presenting view controller dismiss. Okay? So let's look at that dictionary, that info dictionary that comes along with did finish picking media with info, and see what we can get from this UI image picker UI that lets the user take a picture with the camera or do the photo library. So you're going to find there's one thing that tells you what was chosen, image or a movie. Then if it's an image, you're going to have both the original image that was taken and also the edited image if they edited it. And those are just UI images. All right? Then there's image URL. That's the URL for the image. By the way, that is in a temporary location. Make sure you move it to somewhere, you know, in your sandbox that's more permanent if you want to keep it. Crop rect will tell you what rectangle the user cropped it to. If you allow editing, they can crop it to a certain rectangle. You can find that out. You can get some metadata about the media that was chosen, maybe the GPS location that you're at, if the user allows that to be captured, things like that. If it was a live photo that they took, then you get a PH live photo object in there. I'm not going to talk about the photo library framework, which is PH stuff. But you can get that. Also PH asset, which is just a struct that kind of describes the photo but doesn't actually have the image. You can then use it with the photo library to get the image data. And if you have video, then you get a media URL, which is this URL to a file in your sandbox that contains the video that was captured. All right? So that's what you get back from the UI image picker controller. Now, when you get this image back, if you get an image, not a video, but if you get an image, you might want to save it to the camera roll. Okay, now it totally depends on why you're asking them for an image. If it's purely for your app's purposes, maybe not. But if it's something where you're like a camera app of some sort and it's a photo that they might be interested in using in other circumstances, then you can save it using this image right to save photos. Unfortunately, this is asynchronous. Unfortunately, it doesn't use a closure API. Instead, it has kind of target and selector, right? So the callback is a target and a selector. But it's essentially, you can kind of imagine what this would be like if it had a nice closure that called you back. And the reason it's asynchronous is the image might be quite large. In fact, some of the cameras have very good cameras that are very large, megabyte-sized images. And then you talk about a live photo, you're talking about really large images. Now, when you're talking about saving photos, if you're really an app that deals with photos, maybe you manipulate them and you have filters and things like that, really this is only just a the lightest weight API for doing image picking by the user. There's a whole other framework called PH Photo Library, which basically is an API for accessing the Photos app, the photos that are in the Photos app on your phone. Super powerful, very highly efficient API. You definitely want to check that out if you're really doing photo stuff. You could, of course, save the image to your sandbox if you're just using the image in your own app. Okay, that's perfectly legal as well. In addition to PH Photo Library as a place to do really cool media stuff, there's also AV Capture Device. That's a whole API for doing much more sophisticated capture, image capture. Right? You're going to see when we do the demo, the image picker controller has a very simple kind of camera to it. And so AV Capture Device lets you control a lot more of the aspects of the photo being taken. Now, what else can you do with the image picker view? It allows you to actually provide your own UI, even for the button that says take a photo. Okay, so you get this default UI that's very simple, lets you say take photo and cancel and all that, but you can actually put your own view on there, and your view can even replace the existing camera controls. If you say show camera controls is false, then yours will be the only UI that lays on top. The kind of what do you call it, the coordinate system that your frame of your view is going to be in is the UI screen main's bounds. Okay, so we haven't really talked about UI screen. It's just an object. It happens to have a static var called main, and you can get the bounds of that, and that'll tell you the bounds of the camera so that you know where to put your UI on top of that. You can also zoom or translate the image that you're capturing, okay, but with an affine transform. So maybe you want to scale it up so that it is zoomed in or something like that. You can do that. Once you get the image back from the picker controller, you might want to process it, and there's quite a lot of API in iOS for processing images. Most of it is in a framework called Core Image, which I strongly recommend you take a look at. It has literally a couple of hundred different filters for doing blur, changing the colors, you know, doing sepia tones, smoothing edges, just about everything you can possibly imagine doing to manipulate your image, this Core Image will do. There's also, as part of the whole machine learning stuff that came out in iOS, is that iOS 11 or iOS 10? I guess iOS 11. There's a whole framework called the Vision framework. And Vision can look at an image and recognize things like faces, barcodes, things like that. You can even, with machine learning, teach it to recognize, you know, is that a hat? Okay, so you can even do that as well. So if you're doing sophisticated image stuff, again, I don't have time to cover any of this, but just know that it's there. All right, so that's it for today except for the demo. I'm going to do a demo. And what we're going to do is we're going to make it so that in emoji art, we can set our background image with the camera. It's an obvious thing to want to do instead of having to drag and drop from another app. And our next lecture is our last lecture, okay? It's on accessibility. And of course, 1 week from today, you're going to have your final presentations. Be ready to go on that. We're about halfway through your final project, so hopefully you're halfway done, I hope, anyway. And so that's about it. And let's dive right into the demo, unless there's any questions about that. Okay, let's get rid of that. And let's get rid of playing card here. And here we are with emoji art. All right, so hopefully you all remember emoji art from the last lecture. The last lecture was quite a while ago because of Thanksgiving. But here we are. Remember last time we did all these various segues and stuff. Well, what I'm going to do in terms of UI for this camera thing is I'm just going to add a button right here, okay, which is going to bring up the camera. And then when you take a picture, it's going to use that picture as the background. Couldn't be simpler. So let's go add that button. Go down here. It's a bar button item, of course. Drag it out here. I believe, yes, there's a there's a system one here for a camera. Oop, there it is. Looks just like a camera. Now I'm going to connect this up to my code, both with an action and with an outlet. And the reason I'm going to do that is I'm going to check to see if my device has a camera, and if it doesn't, I'm going to disable this button. Okay? And I told you always have to check for the device, and that's how I'm going to check. So let's do that. Let's go over here. It's in wide. Here's, let's put all our camera stuff at the top. Mark camera. All right, so let's go over here. I'm just going to control drag. do the outlet first. We'll call this my camera button. And then let's do our action. And of course it's going to be part button item type, and we're going to call this, how about we'll call this take background photo, because that's what this button does. It takes a photo that's going to be the background. All right, that's it for our UI. We don't have to do anything more there. So let's implement this stuff. Let's start right off with the camera button. I'm going to, right when it's set, I'm going to enable it or disable it depending on whether I have a camera. So I'm just going to say that my camera button.is enabled equals my UI image picker controller dot is source type available dot camera. Okay, so here's where I told you we got to test it. I'm testing it right here. Okay, so users aren't even going to be able to get into this code down here if we don't have a camera. All right, taking a photo, really easy. We just create the picker, UI image picker controller. We're going to configure it to have the right source type. We want the camera. Now, again, we could do photo library and stuff here. If we did photo library, though, that little camera button would be bringing up a popover. Okay, but here we're doing the camera, so it's going to be full screen presentation. We want an image here, so I'm going to say the media types equals an array that has KUT type image. Okay, and this is not turning purple because it's not recognized, because I have to go up here and say import mobile core services, only just to get that one symbol. That's the only reason I have to do that. And now it's complaining that it's a CF string, so I'm going to say as string. Okay, so that's the types I want. I just want images. I don't want video. I just want images in this case. And oh, sure, we'll allow editing. Allows editing. True. Why not? Most importantly, we got to set the delegate to ourselves, or we'll never find out about anything the camera did. And then we can just present this picker, animated true, of course. Now we're going to have an error here, of course, because we're saying delegate equals self, but we don't say that we are a UI image picker controller delegate. And you'd think that would be enough to, when we compile, get rid of the error, but it says, whoa, cannot assign value to UI image picker controller delegate and UI navigation controller delegate. What? Why is it saying that? Well, unfortunately, the UI picker controller, I believe it's a subclass of UI navigation controller, so you have to be its delegate as well. So we just have to say UI navigate. This is a case, by the way, where the fixit down here, you do not want this fixit. This fixit is to cast self to be these things, which it's not. So be careful with fixit. It's not always the right thing. So here I'm going to be a UI navigation controller delegate as well. Luckily, neither of these have any required methods, although in UI image picker controller, they should be required because you really can't do anything without them. And let's jump right to those delegate methods. There's only two of them. So image picker, there's this one, which is cancel. And then there's this one, other one, image picker controller, which is the did finish picking media with info. And in both of them, I'm going to say the picker's presenting view controller, dismiss, okay, when it's time to go away, animated, true. Now, who is the picker's presenting view controller? That's us, because we're presenting it. So I could actually just get rid of this, right? This would actually be okay. But I kind of like to do this explicitly. Just, I don't know, for some reason, it just, you know, because of that, dismiss has that weird thing where it'll look to see if you're presented by the person and present. I like to have it explicit to be the picker's presenting view controller. What if I put up another view controller that presented the camera and then it was unwinding back to here or something like that? I don't know. So I like to do that. And I want to do this in both places, both when if it's canceled or whether it successfully picks some media here. All right. So now we have this image picker controller, and it successfully picked some image or whatever that we want to use. How do we get that image out of there? Well, it comes out of this dictionary right here. So we're going to look in that dictionary. I'm going to say if I can let the image equal that info dictionary, and I'm going to look at the key UI image picker controller edited image. Okay? I allow editing, so I'm going to do this. Now, notice that the type in the dictionary is any, because that might be a UI image, it might be a URL, okay, it could be a PH live photo. So it's any, so we are required here to say as a UI image. Okay, so this gets the image. Now, I'm going to do two other small things here. One is, I'm going to actually say if this is nil, because maybe I went back and changed this to false in the future, then I'm going to also back up by grabbing the UI image picker original image. Okay, so basically I'm just, if I ever change this, I want the rest of the code to still work. So I'm just kind of, if this is nil, then I'm going to grab this one instead. The other thing I want to do here is shrink this image down a little bit, because some of these cameras are huge. This image would be 4 megabytes in size. And in emoji art, you usually don't want the emojis to be these tiny little dots in a gigantic image, right? So the emoji only has so much resolution. So I'm going to shrink this down, and I'm going to do that with a little function that I have in my utilities called scaled by. And scaled by is the world's cheapest little image scaler. It actually scales it not even by the area of the image, but it scales the edges by that much, which is kind of a freaky way to do it. But it's simple code, and you can go look at it. It's in the utilities.swift that I provide with emoji art. Okay, so now I've got the image I want, hopefully, right? If let, so hopefully I got the image. Now I need to set this as my emoji art's background, right? Well, because we wrote our code so nicely, we can just say emoji art background image equals. Now I want to say image, but do you remember what this argument is? It's a tuple. Remember that? We changed that to a tuple. Uh-oh, what am I going to put as the URL here? Because I got that image directly from the camera. I don't have a URL. So I'm going to have to, for now anyway, and if I have time I'll show you a better way, I'm going to have to create a URL for this thing. Okay, and I'm going to create a URL in my sandbox, okay, that stores this image. I actually have a little utility function to do that as well. You can go look at that in the code. So I'm going to say, so I'm going to create that. Also, the other thing we want to do, by the way, is note that our document has changed here, right? If we set our background image, then our document has definitely changed. So I'm going to create this little URL, let URL equal, take my image, and the function I have is called store locally as JPEG with a name. So that's what this does. It takes a UI image, right? This is a UI image extension method, and it stores it as a name. Now I need a unique name for this thing. A really great unique name is the current date as seconds since January 1st, 1970. Okay, turns out an easy way to get that, which is date, time, interval, since reference date. Okay, of course, this is going to be seconds, so that's a double, so I'm going to turn it into a string by just stringifying it here. And now I have a nice unique name for this JPEG. Now, I hate this because I just took a picture with the camera, and I'm having to create this random file in my file system. When am I going to clean this thing up? Okay, I'm going to have to find out when my document was deleted somehow, or and what about on iCloud? This is not going to work on iCloud. If I open this on another device, it can't see my sandbox on this other device, so this is terrible. Okay, now we're going to be close on time here, so I don't know if I'm going to be able to show you how to fix this, but I don't like this, but we're going to do this just so that we can see this all working, so you can see the camera API working, etc. Okay, so let's do that. Let's take a look at this. Let's go to our iPad here. So here's emoji art. Let's create a new document here. I just pressed create new document. And you can see we got our camera up there in the upper right. And notice that it's also enabled. That's good. That means we have a camera on this device. So I'm going to click that camera. Okay. It's going to load up the camera, bring up this. Here it is. We're going to do a blast from the past right here and go our picture from our concentration. This is kind of nostalgia day here. I've gone back to playing card and this. So here, let's try to take the picture without that shadow in there. There we go. And here's what I was talking about, where I can zoom in on this or change the cropping rectangle because we allow editing. So we'll do that, and I'm going to hit use photo, and we're going to see if this is going to work, and it doesn't work. Now, why this doesn't work, you're like, oh no, I got to go debug this. This couldn't possibly not work. This is one of those cases where you look at our code, it's so simple here, it couldn't work. Well, actually, this doesn't work, believe it or not, because of the view controller lifecycle. Okay? When we press that camera button and bring up the camera, it actually covers up our view controller entirely. And then when it goes away, view will appear gets called on our view controller. Do you see why? Because it just appeared. It was covered up and the camera went away and now it appeared. Well, let's take a look at our view will appear down here. Here's our view will appear. What do we do in view will appear? We open our document. Okay? And we open it no matter what. So if it's already open, we open it again. We go back to disk and get it again. That's what's happening here. It actually was working. It put that image in there, but then it reopened the document and went back to blank because it was an untitled document. So this is a simple fix here. We're just going to say if our document state is not normal, then we'll open our document here. Okay? But that's this was kind of a tricky bug. When I went to add this before class, I was like, oh, why doesn't that work? And so this was a little bit of a tricky one there. But this will fix it. So let's go back up here and get this code on screen for our camera here and run again. We'll bring our untitled document up again. Oops. And then screen so you can see it. All right, so we've got our untitled document. So I'm going to hit the camera button again. We'll go up here. Let's take our photo, get it in focus right there. Our cute little guy there. Okay, so if this now I'm going to say use photo, and sure enough, here it is. Okay, here's our photo, and we can add apples or whatever, maybe like a bee caught in the web up there. Makes sense. And we're done. Hopefully we'll get a thumbnail there. We even get a thumbnail. That's great. Okay. Now, let's talk a little bit about what I was talking about where this is bad because it creates a little local file for this. How are we going to fix that? Well, I'm going to fix that at light speed here because we have 10 minutes left. The way I'm going to do it is I'm actually going to store the camera's image in my emoji art document. Okay, so I'm not going to store it as a URL, a separate thing. I'm actually going to store the data embedded in my document. Okay, that way it'll work in iCloud and all this stuff. I won't have to create the URL. It's going to be great. Now, I'm not going to do that for documents that do have a URL because I don't want to duplicate that image. No need to do that. We'll just go out on the internet and get it. But for cases where I don't have the URL, I'm going to do that. So let's, again, at light speed, I'm going to limit the explanation here because time constrained, but I think you'll learn something from doing it. Let's go do it. And now, the first thing I need to do is go back to my emoji art model and make it capable of having the image, because right now it has to have a URL. So I'm going to make having a URL be optional and have a new one called image data, which is just a data object. Notice this is not a UI image because this is not a UI thing. This is my model. And since I can have now either URL or image data, I'm going to go down to here and have a different initializer, or another initializer actually, that lets me initialize an image data based. Oops, not image data, data. Oops. This is image data equals the image data. Okay, so now I can create my emoji art with either URL or image data. Now, what about Codable? What about turning this to JSON? Is this all just going to work? Well, yeah, no errors, right? And in fact, it is going to work because Codable knows how to deal with optionals. It knows how to write out datas. So this is all perfectly fine. It's all just going to work. So that was easy. Let's go back to our emoji art view controller. Now, what's the problem here? Well, the real problem over here is this method right down here. Okay, this is the core of the problem right here. Okay, this is our emoji art background image, which is that tuple. Remember the tuple we had? Okay, well that tuple has a URL and the image, but now it might be image data and the image. Okay, so we have to fix this. This can no longer be this tuple. It has to be some other type that's either a URL or it's the image data. Now, what kind of data structure do we use when something is either one thing or another? What do we use? What? Any, we could use any, but that's not very Swifty. Enum, absolutely. Let's use an enum here. I'm going to say enum image source, I'm going to call it. And it's going to have the remote case, which has a URL and the UI image. Okay, and it's going to have the local case where it's an image data and the UI image. Now for convenience, I'm going to create a var. Notice they both have UI image, so I'm going to create a var called image here, which returns that UI image. And I'm just going to do that by switching on myself. And in the case of a remote, then I don't care what the URL is, but I'm going to get the image back here and return it. Okay, and in the case of local, I don't care what the data is, I'm just going to get the image and return that image. Okay, so this is just a nice little convenience var, so I can get the image no matter which one it is. All right, so now I'm going to change this. I'm going to change this tuple to be an image source, which has to be optional because we might have a blank document. It has no background, so we'll have to leave that optional. And I'm not going to have it be a computed var anymore. I'm going to have it be stored, and I'm going to use didSet to do all this stuff down here. And I don't have to keep the URL separately anymore because it's built into the image source. And everywhere where I did new value in the computed sense is now this thing, okay, which is optional, so it might be optional there, so this is also optional. And the image, which is this var I just created right there, is not optional, so we'll take that away. So this is great. I just fixed it, okay, emoji-heart background image. Now, of course, we need to go all the places we set and get this, okay, to fix it to work. Well, let's start with our camera, where we set the camera. That's right up here. This is the code right here where we say URL image. Well, I don't want to do URL anymore, so I'm going to get rid of that. So that clearly makes this be the local case where I'm going to have image data and the image that was passed in. So where do I get the image data? Well, we know how to do that. I'm going to say if I can let the image data equal the UI JPEG thing, this thing right here, UI JPEG image representation of the image. We'll have a lossless compression right there. And as long as we're able to do that, then we will do this. Otherwise, I probably have a to-do here to go and put up an alert user of bad camera input or something, okay? Because I wasn't able to turn the thing from the camera into a JPEG for some reason. I don't know why that would ever happen, but I should probably put up an alert here. Okay, so we fixed that one. Where else do we do this? Well, we do it when we drop, okay, right? When we drop an image in, drag and drop a background, of course we do it there. Now here, look at all this stuff we did last lecture to go put up an alert if the thing we dropped in, we couldn't get the image. Actually, we don't have to do that anymore. Because now if someone drags in a bad URL, we can use the image, use its image data. So I'm actually going to get rid of all of this stuff that we did last time. What a waste of time last lecture was. And instead, I'm going to go back to exactly what we had before, which is use the image fetcher. Okay? But what I'm going to do here is, well, first we've got to update this, right? So this is the background image in the image fetcher world. So this is remote with the URL and the image. However, what if we had to resort to our backup image? Because then it's not really remote. Now it's become local. So I'm going to say here, if the image was the image fetcher's backup image, then I'm going to do one thing, else I'm going to do another. So the else is to do the normal remote case because I didn't use the backup image. But if I do use the backup image here, this becomes local, and we have to have the image data here, data. So I need to get the image data here too, so I'm going to say if I can let image data equal that UI JPEG thing, there it is, image, compression, lossless. Let's go in here, then I'm going to do this. What am I going to do if not? If I wasn't doing it, you know what I'm going to do? I'm going to present that warning thing. What was the name of that thing? Bad URL warning, bad URL. There it is, present bad URL warning for that URL. That same alert that we were doing before, I'm just going to present that if I wasn't able to take the image that was dragged and get its image data. Again, I don't know why I would ever not be able to, but yeah, let's make our code. Okay, good, woohoo. Now, every single place where we set the background image, both the camera and the other one, is now setting it to this nice enum here. What about where we use it? Okay, well, the primary place where we use it is right here where all this red is, which is our model, right? Because someone sets an emoji art model, and we have to obviously get the right data out of there somehow, or they're asking for it, and we're going to give it back to them depending on the two different cases. So let's do the get case first. It's quite simple. Where instead of looking at the URL, now I just need to look at this image source thing. emoji art background image, get the image source. I still want to do this, which is to get all the emojis, but I'm only going to call this URL one here if this image source is the remote case. So I'm going to switch on this image source, and if it's the remote case, where I'm going to grab the URL, and I don't care about the image in this case, then I'm going to do this. All right, and what if it's the local case, okay, where we got this image data? No, then I'm just going to return an emoji art that takes image data instead. Right? That's it. So that was easy. The get case of that was really easy to do and obvious what we're doing there. What about the set case? A little more complicated. First of all, we don't do the tuple nil nil. We just say nil because it's an optional image source right there. Still want to do this. Still want to check and see if there's a URL and try to go fetch it if we can. And if we can successfully fetch it, then we do want to do remote URL kind of image, just like we did before. Now, I'm going to do the same thing here that I did with drop, which is I'm going to use any image data I can find in the emoji art that you're setting on me and use it as the backup image. Okay? So let's take this down here and say image fetcher.backup equals the image that's in the emoji art that you're passing me. So I better create a var for that. So I'll get the image data out of the new value. And then I'll get the image by saying, well, if the image data is not nil, then I'm going to return a UI image from that data. Otherwise, I'll just return nil. In other words, there is no image data in that emoji art, so I can't use it as a backup. Okay, in that case, I'm not going to be able to load this, which is fine. That's no different than it was before. All right, so there's our image fetcher backup image. So now we'll just say image fetcher, fetch that URL. Now, when that comes back, okay, we have to do the same exact thing we did down with drop, is check and see if we used the backup image. Because if we use the backup image, we're in the local case. So I'm going to say if the image that we used equals our image fetcher's backup, then I'm going to use the local case with image data, right? This is the image data from up here, which we know this is going to not be nil because we wouldn't have gotten this to be not nil if this weren't nil, so that's fine. Now, what if the thing has no URL at all? What if we have an emoji art and it has no URL? It's just image data only, so we better handle that case as well. So here I'm going to say, where's the other side of that if? Here it is. I'm going to say else if the image does not equal nil, in other words, it has no URL, but it does have an image, then I'm just going to use the information here that we have. I don't think I have to say self there. Why is image else? Where are we here? Else if. Sorry. So here I can do this, set this emoji art background image stuff using the stuff we have directly from the emoji arts image that came through. So we just here set our emoji art background image here to be the local case with the image data and the image. All right. Unfortunately, I also need to do this right here. Do I have time? No, I don't. This really wants to be put into another function, right? You never want to copy and paste code like that, but we have 30 seconds left, so I'm not going to leave that. So hopefully I did all this and it's going to work. Let's try. It's the world's fastest demo here. Okay, so I'm going to make a new document since the other document was with the old style. So let's go ahead and use our camera. Oops, sorry. Let's cancel. All right, so I'm going to use the camera here. Let's get our fun guy again here. Oops. There we go. Zoom in on him a bit. We'll use that photo. So we have this photo here. Let's put, again, bee up here flying near the web. So now when we close this here, hopefully we can see this on other devices. So let's go over and run this on a simulator. All right, here we go. We're on our simulator right here, so totally different device than our iPad. In fact, I'm going to get them both on screen at the same time here. Let's make this a little bit smaller. So we've got these two different devices, and we can see that via iCloud, we're on iCloud Drive, that this document that we created right here has appeared. So let's open it up. And sure enough, we can see it with the background image because it's not referencing it by the URL anymore. It actually brought the image that we dragged in, or in this case that we've selected with the camera, into our document. And we hopefully we should be able to add something here, put a little apple on here, and that'll save it up to iCloud Drive. You can see right here that it's in the process of uploading it. Over here in my device, you saw it just download there. So if we go here, hopefully, well, there we go, we have our apple. Okay. So that way we're able to share our document across iCloud Drive, even though the background image was something we captured with the camera on a specific device. All right, so that is it for today, and we'll see you next time for our very last lecture, which is going to be on accessibility.
For more, please visit us at stanford.edu.